So what this is called, I'll move out of the way. It's polar graphs of conic equations, okay? And this is a very wordy kind of explanation, and I have to kind of think about what it means a little bit. But it says, let E denote a fixed line called the directrix, and F denote a fixed point called the focus, which is not on B, and let E be a fixed positive number called the eccentricity. A conic is a set of points P in the plane such that the ratio of the distance from F to P to the distance from D to P equals E. That is, a conic is a collection of points P for which this is true. And so, in other words, if you're looking at, I'll show you kind of with the three different shapes. If you're looking at a parabola, okay, and it doesn't matter, let's do a sideways parabola just to talk about this one. And what we're going to be talking about with all of these conic sections, they could be defined this way, and the focus, or at least one of the foci, is always going to be at the origin, okay? And then we have this line we call the directrix, okay, over here somewhere. And in a parabola, okay, the distance parabola is defined as this distance over this distance being equal, right? And so for a parabola, the distance from here to here, whoa, that's really big. Come on. The distance, where's my undo button? Okay. Let's see if I can do a straight line without arrows on it. Let's try to make it dot. Okay. So in a parabola, the distance from here to here over the distance from here to here is always equal, right? And that is known as this divided by this in a parabola is always going to be what? 1, right? Because that's kind of the definition of a parabola. The distance from some fixed line called the directrix, okay, is always 1. And we're going to be talking about parabolas like this. Also, E is equal to C over A. So in a parabola, that C is the distance from the, so C, for any of these, okay, C is always going to be equal to the distance from the, well, there is no center in a parabola. In a parabola, that C is going to be the distance from the focus to the vertex, and A is going to be the distance from the directrix to the focus. But in a parabola, those two distances are the same, okay? But that's not true for the other conics, okay? But for a parabola, that number E is equal to 1, okay? For an ellipse, that number E, the eccentricity it's called, and the eccentricity is kind of a measure of how stretched out a figure is less than 1. For example, okay, let me do a different picture. Can I erase this? Sure, you can erase it. Go ahead, I'm going to erase this. So say I have an ellipse. Well, let me see if I can draw an ellipse with my shape tools. Shape tool. I think this is more of an oval than an ellipse, but say I were to do something like that, and I have an XY axis, and this is where it gets a little bit weird, okay, is that it's a little bit different in that it's kind of not centered at the origin when they do these polar graphs, and this is one of the foci of your ellipse, okay? And if the ellipse is going this way, which we'll talk about these equations in a minute, then the directrix is going to be somewhere over here, okay? And it turns out that in an ellipse, the distance from, let's do yet another color, the distance from a focus to a point on the curve, okay, and the distance from here to here. So this is the distance from the focus to a point on the curve, and this is the distance from the directrix to another point on the curve. this over this for an ellipse is always less than 1. Okay? You understand that? And so if I had another focus, and you might be thinking, well, that's not true about my other focus over here. I want to show you that that would be true, okay? So if I go, say this is kind of where my other focus is. This is focus number 2. The distance from here to here, okay, over the distance from here to here. Do you see that that's going to be less than 1 as well? Hello? Yeah. Okay? So that's always going to be true for an ellipse, okay? For what?
If you go from the second focus along the x-axis all the way to the edge.
Yeah, but to any point on that ellipse, the distance from here to a point on that ellipse versus the distance.
That would be big.
Oh, that would be bigger, wouldn't it be?
So wouldn't the diagram just be farther away?
Wait, I'm getting confused. So what this smart student said is that mine is probably not drawn to scale, right? The directrix is probably further away. So that the distance from this point to the curve, right, over the distance from here to the directrix is always going to be less than 1. Okay? Thank you. With a hyperbola, let's see if I can draw a hyperbola. What's this? Let me see. Never mind. Let's erase this. And let's draw. How do I erase that thing? I think I have to click on it. Boom. And I could go edit. Delete. Cut. Okay. So if I want to draw in a hyperbola with one focus at the origin, okay, which they call the pole in this case. They call it the pole, and they call this the polar axis. This is called the pole. And if I were to draw in a hyperbola with one focus here, so here's a focus, and one part of the hyperbola is going that way, and here's the other focus going that way, okay? I mean, excuse me, here's the other focus, the other half of the hyperbola. But one focus is always at the pole, and in this case, the directrix is somewhere in between these two curves, okay? So it's somewhere in here, and I'm not sure where it's further, which one is further from. But with a hyperbola, the distance from here to here over the distance from here to here is always greater than, okay? And so that's the eccentricity for a hyperbola is always bigger than 1. So let's kind of see how that could be true. Like over here, this line over this line is always bigger than 1, okay? And to find out what that eccentricity is, you could take C over A. If you remember with a hyperbola, we're going to do this, but A is the distance to the center, okay, from the vertex to the center, and C is the distance from the focus to the center. And if you take C over A, you will get exactly what that eccentricity is. Okay? Yes? No? Sure. Whatever you say. All right. So then these formulas are the ones you're going to use on these types of problems, where it says discuss the graph of the equation and graph it and all this kind of stuff. So we're going to work through a couple of these, which is kind of a little bit confusing, but we're going to do it anyway. And I think on a test, I'll give you all these formulas, okay? Because they're hard to remember, and I can't remember them either. I can, but so I'm going to break out my notes now. First, I'm going to pause. So the first one that we're going to look at is this one right here. It says discuss the graph of the equation. And that doesn't just mean discuss it. It means sketch a graph of it, plot most of the points of it, and the x and y intercepts. What else? Find A, find B, find C, find the eccentricity, tell what kind of shape it is, and all this kind of stuff. So there's lots of things that you have to do. So first of all, this is a polar equation. So if you're plugging this into your calculator, which I'm going to try to do after I show you this, you would you'd have to be in polar mode, and you have to put you put in r, and then you put in 4 over 2 minus cosine theta, and it will actually do this for you. So your first step is to determine what kind of shape this is, okay? And in those formulas that you have on your sheet, right, you want that this number right here to be 1, okay? Because all of those formulas have a 1 right there. Do you see that? And the way that you do that is you divide everything by 2. Does everyone see why I divide everything by 2? Okay? Because I want this number right here to be 1. Okay? So I have r equals 2 over 1 minus 1 half cosine theta. Everyone see what I did? Okay, divided everything by 2. And when I do that, that tells me, okay, since this is, this on the top is EP, right? Where's that formula? I don't have the formula sheet in front of me. On the top, this is EP, right? And you know that on the bottom, this number is E, right? And so this tells you that P has to be what? 4. Does everyone see where that came from? From the formula, we have this formula, R equals EP over 1 minus E cosine theta, right? So we know just based on this, the look of this thing, that the eccentricity is 1/2, all right, and that P is 4, and we'll talk in a minute what P is, but P is the distance from the directrix, so that helps us locate the directrix. So based on this, if E is 1/2, what shape is this? E equals 1/2. It's less than 1. No. Yep. Sorry. Yes, it is. It's an ellipse. Okay? So it's an ellipse. And P equals 4. We also know that since it's cosine here, this tells you that this is a, let me draw some lines in here. Okay? Its directrix is perpendicular. Isn't that what it says? 1 over, in that form it says the directrix is perpendicular to the polar axis at a distance P to the left of the pole. Okay? So what does that mean? That means that this is, there, for all of these, one focus is at the pole. So this is focus 1. Okay? And the directrix is perpendicular to the polar axis at a distance P to the left of the pole, which means the directrix is going, let's change colors, it's going this way, okay? And it's over here at what? X equals -4, okay? And that's the directrix. Now the directrix doesn't really help you in determining what the graph looks like. All it does, it's a way of generating this ellipse. So now, oh, maybe I could try to use my ellipse. Oh, I'm not going to draw it in yet. Okay? So the first thing that you want to do when you're doing this is make a little table of values. The other thing I know, since the directrix is going this way, and one focus is right here, the ellipse is going to look something like this, okay? So if it's cosine, the ellipse is going to be going this way with the 2 foci on the polar axis. If it's sine, the two foci are over here, okay, and the ellipse is going to be going this way. This is like the y-axis, this is like the x-axis, except they call this the polar axis over here, and they call this the pi over 2 axis, okay? So what you want to do is plot some points, and what you're going to do is you're going to have an r and a theta, and the first one that you want to plug in for theta is 0, and probably the second one that you want to plug in for theta is pi. And then we'll talk about pi over 2 and pi over 2 and 3 pi over 2. So when I plug in 0 into this equation, and you could plug it into the original equation. Let's go back to our original equation. R equals 4 over 2 minus cosine theta, okay? When I plug 0 in here, what's the cosine of 0? 1. 4 over 2 minus 1, right? So you would get 4 over 2 minus 1, which is 1, you get out 4, right? So when theta is 0, r is 4. What that means, if I'm counting out here, one focus is always right at 0, 0 for the pole, okay? So 1, 2, 3, 4, and rotate through 0. There's a point on that axis, okay? Now if I plug in pi in here, okay, what's the cosine of pi? -1, right? Okay? And so 4 over 2 minus -1 would be 4 over 3. Do you see where that comes from? That's -1, so it's 2 minus -1, which makes 3. So it's 4 over 3. So when I go to pi, I get out 4/3. Now the way that you graph that point is by going out 4/3, which is a little bit more than 1, right? 1 1/3, and then you rotate around, and so over here, if this is -1, then this is the point, other point that I'm talking about over here, okay? And since I know this is an ellipse, these have to be the whats of that ellipse, the vertices of that ellipse. So now if I were going to sketch in this ellipse, let's see if I can do this. I'll try, okay? Can I start it here? Let's see, maybe I can move it after I do this. I'm going to get that, then I'm going to slide it down, okay? Try to. Come on. How do I grab this thing? Hello? Oh, I did it. I did it. There. Now how do I slide it down? Here? Ah! Maybe up there. There! Ooh, perfect. Okay? So this is kind of what my ellipse is going to look like. Okay? So then what I want to do, I want to find what these 2 points are as well. And the way I do that is plugging in pi over 2, because that's that point. Okay? It's probably going to give me that point. Maybe it'll give me this point, but it's going to give me one of these 2 points, because I might rotate, I might go negative. It might give me a negative number. So let's plug in pi over 2. What's the cosine of pi over 2? 0. So 4 over 2 minus 0 gives me 2. So if I were on this, so this, it should be more stretched out than this is, but this is the point in rectangular form, 0, 2. And then if I plug in 3 pi over 2, that also comes out to be 0, right? The cosine 3 pi over 2 also comes out to be 0. So I get out a 2 over there, okay? And so this is the point, it's 3 pi over 2 in polar form, but in rectangular form, this is 0, negative 2, right? Okay? And then this point over here is going to be in polar form, it's 0, 4. In rectangular form, it's 4, 5. That doesn't look comma 0. Okay? And this point over here in polar form is 4/3 comma pi, but in rectangular form it's negative 4/3 comma 0. Do you guys see that? Yes? Where that comes from. Now, when you discuss this, you also want to find C and A and B, which is kind of a pain. That's kind of the hard part. Okay? So C is, and you want to find the other focus. Okay? So the first thing I'm going to do is find the center. Okay? And the center is going to be between, is going to be in the middle of these 2 points. See that? Okay? So to find the center, I'm going to average the 2 vertices. So I'm going to go 4 plus negative 4/3, and I'm going to divide that by 2. You're finding the midpoint between those 2 points. You understand that? Okay? So, and it's going to be, the y coordinate is going to be 0. So then you got to do some algebra. Okay? This is 12/3 minus 4/3 gives you 8/3. 8/3, I believe, divided by 2 is the same as multiplying by 1/2. 1/2. So I get 8/6. Did I do that right?
Yes.
Which is the same as 4/3. So the center of this is at positive 4/3 comma 0. Okay, so that center is at 4/3 comma 0. And what that also tells me is that then I can find C and A. Okay? Can I go down here? Sure. So C is the distance from the center to one of the foci. So what is C? What's the distance from here to here? 4/3. Does everyone see where I got 4/3 from? And since this is a point 4/3 0, and this is the left focus, right? And that C is going to be, C is 4/3. This is talking about the formula C squared, remember this, for ellipses equals A squared minus B squared, because I want to find B as well, because I want to see what the stretch is of this one. Okay? A is going to be the distance from the center to 4. Okay? So that's 4/3. That's 4. So if I go 4 minus 4/3, that's 12/3, right? Minus 8/3. 12/3 minus 4/3. A is going to be 8/3. You follow that? That's equal to 4 minus, is the distance from here to the center. Okay, so that's 4 minus 4/3. So that's going to be, that's 8/3, which I already told you that. Okay? And then the reason I wanted to find C and A is because I want to find B. Okay, so now you got to be good with fractions. So you go 4/3 squared equals A squared, which is 8/3 squared. Squared, sorry about the messy line there. I'm not going to even try to erase that. Squared minus B squared. And so when I do that, I get 16/9. I get 16/9 equals 64/9 minus B squared. And so then I subtract 64 from both sides, and I get, I'm going to go down more, I get 48 negative 9ths equals negative B squared, which means that B squared equals 48 9ths. And I'm really just concerned with the positive part of this. So B is equal to the square root of that, which is the square root of 48 over 3, right? And the square root of 48, one more down, I'll go over this time. Okay? Square root of 48 over 3 can be written as square root of 16 and the square root of 3. So it's equal to 4 root of 3 over 3, which Ross said is about what? Oh, you didn't say? I know that root of 3 is 1.7. I don't know what that is.
It's like 6.8.
About 6 point something? 6.8? Couldn't be 6.8.
It's 2.8, and then you divide it by 2.
It's about 2.3 or something like that. So in other words, if I go back to my graph, which I don't know how to do, can I do that? Can I drag this down? Ooh, I'm getting good at this. Okay. So if I go back to here, this point right here is, that would be the point 4/3, comma, up 4 root 3, or that one would be down 4 root 3 over 3, and this other one would be up 4 root 3. See that? And then one more thing they're going to want you to find, and that's the other focus, okay? Well, since this focus is 4/3 away from the center, the other focus is going to be 4/3 away from here. So that other focus, if I add 4/3 to 4/3, I get 8/3, right? Which is 2 and 2/3, is that right? 2 and 2/3. So about here would be your other focus. So over there would be focus 2, and that would be at 8/3, comma 0 if I'm in rectangular coordinates. So that's what it means to discuss. It means to find A, tell what type of shape it is, tell what A is, tell what B is, find the two foci, and then sketch the graph of it. Follow that? It's a lot of steps. Okay, you only have like 3 homework problems like that. So real quick, I'm going to do a parabola. Parabola is easy. Okay? So let's go back and let's discuss this one here. All right? And so I'm going to capture this. And again, you kind of follow the same process. I want to get this number to be 1 over here. So what do I divide everything by? Divide everything by 3, right? So I'm going to divide this by 3, I'm going to divide this by 3, and I'm going to divide this by 3. And so what I get is R equals 2 over 1 plus sine theta, right? Is that right? That's right. Okay, so I know that E equals the number in front of here, E equals 1, right? Which means that tells you what it is. That tells you that it's a parabola, okay? Parabola, okay? And this is E times P, right? So P equals 2, right? Because E is 1 and this is E times P, so P equals 2. And remember, P is the distance, okay, from the vertex, in this case, to the directrix. And so now I'm going to, yes ma'am?
I just want to do, how come then for the first one when you did P equals 4, like in the first equation, like before we divided by 2?
Before I divide it by, to continue, I know that since this is sine, and it says in your on your little sheet there, it says the polar equation of a conic with focus at the pole. Okay, so what's nice about a parabola is you only have one focus, right? And then it says the directrix parallel to the polar axis at a distance p units above the pole. So the directrix is going to be up here somewhere, okay? Up at 2 units above the pole. So this is the line, this is the directrix of that parabola, and that's the line y equals 2, okay? So since the focus is down here, how is this parabola going to look? And the directrix is up here. It's going to be looking like that, right? Okay? So then I know there's going to be 2 points over here, and those are really easy to find with the parabola. Okay? All I have to do is make a little table, r theta, and that's a theta, not a 0. So when theta is 0 in this equation, you could plug into this one. It's actually easier than this, right? So 2 over 1 plus, what's the sign of 0? 0. So when I plug in theta, I get 2 over 1, which is just 2. So I have a point on here which is out 2 and rotate through 0, or in rectangular form, that's the point 2 comma 0, right? Okay? Over here, I'm going to plug in to find the other side. I'm going to plug in pi, right? And when I plug in pi, what's the sign of pi? 0. So I get 2 over 1, which is 2 again. And so this says come out 2, and then rotate through pi, which puts you over here in rectangular coordinates at -2, 0. Now I could plug in another point to find the vertex, but I know with a parabola that the vertex is halfway between the directrix and the focus, right? Because this distance from here to here, which is a, or p, and this distance from here to here, which is a, well, they're really the same thing, okay? So this parabola looks, this is the point over there, that's 0 comma 1, okay? And so this one looks like that, and for the parabola, that's all you really need to do.
Where did you get the point
0 comma 1, because I know the directrix is at y equals 2, right? And I know the focus is at 0, 0. So the vertex has to be halfway. The other thing I could have done is plugged in pi over 2, right? And if I plug in pi over 2 over here, I get 1, and I get 2 over 2, right? Which gives you out 1.
It doesn't matter if like you write the coordinates in polar form.
What?
Can you write it in rectangular?
Yeah, on the graph, write them in rectangular form. When you're making the table, make it in polar form. Okay? Now, just to show you a couple things, I'm going to see if I can do this on my graphing calculator and how you plug one of these into your graphing calculator. So, let's see if I could do that. Can I move this thing? Move this. Move this. What's this thing? Boy, I got enough windows open. Get rid of this thing. Okay, so let's see. On your graphing calculator, say I want to do that first one, which is more interesting. Now what's nice with this, see these, if you try to graph an ellipse in rectangular form, then you have to break it into 2 functions. In polar form, r is a function of theta, so you can graph the whole thing in one shot. You don't have to break it into a positive part and a negative part. So, you got to use the right end of the pencil here. And I'm going to go to mode and make sure you're in polar form. Okay? And then let's go to, if you hit the y equals, an r will come up. Okay? And I'm going to go, my first equation was 4 over 2, 4 divided by 4 divided by, where was it? 2 minus cosine theta. So I'm going to put in parentheses 2 minus cosine theta. Okay? And I want to make sure that I have I want to parentheses around this and that, like that. And I'm going to go to my first I want to make sure I'm in radian mode. See, that would mess me up. Okay? So, whoops. Make sure you're in radian mode. And the other thing, when I set up my window, it looks like I'm going from 0 to 2 pi, which makes sense. And I want to go from -10 to 10. Probably a little bit smaller than that would be better, since our vertex was out there at like, what was our vertex? At 4, 0. So let's go from like, -5 to 5 instead. Okay, so -5, -5 to 5. And same thing on the y. Let's go from -5. Whoops, that's -5. Delete. Delete. Oh, change that. Just change that into 5. -5 to 5. And let's pray and see what happens. Graph. Pretty cool, huh? So it graphed the whole ellipse in one shot, okay? And you could graph a whole hyperbola. Hyperbolas, I think, are actually, it's about the same as an ellipse. I'm not going to do that one since we're almost out of time, okay? So I'll let you try that on your own. Maybe I want to do one more thing. I think I do. The last question, did I pause? No, I didn't pause. So the last question, let's go back. Will this take me back to the last question? Let's get rid of this, or at least minimize it. Where were my notes? Workspace. I don't know. I have to go back. Oh, not here. Do I have to reopen it? Should have just hit documents, chapters, take out the dates, chapter 9. Where'd my 9-6 go? What happened? It disappeared? I don't know where it happened. But the last problem asked you to convert something from polar to rectangular form. Let's just look at that. Where's that one? R equals 3. I can do that. So if I wanted to convert from polar to rectangular form, R equals 1 over 3 minus 3 cosine theta. What I want to do first is cross multiply. So I get R times 3 minus 3 cosine theta equals 1. Okay? And then I want to distribute. So I get 3R minus 3R cosine theta equals 1. And then what do I do here? So this is where it gets kind of tricky. What they tell you to do here is bring this onto this side. So I'm going to write this as 3 as mess. I'm going to erase that. I'm going to write this as 3R equals 1 plus 3R cosine theta. And then I'm going to square both sides. Okay? Square both sides. And so this gives you 9R squared. And before I square both sides, I'm going to call this, what's 3R cosine, what's R cosine theta equal to? X. So I'm going to change this to 1 plus 3x squared. But I also know that R squared is equal to something. What's that equal to? X squared plus y squared. Okay? And then I FOIL this out. So I get 1 plus 3x times 3x twice, so you get 6x plus 9x squared. And then what's nice here is you get 9x squared plus 9y squared equals 1 plus 6x plus 9x squared. What happens to those x squareds?
They go.
Bye-bye. This goes away, this goes away. So you get 9y squared equals 1 plus 6x. What's that the equation of? That's equation of a sideways parabola, right? 9y squared equals 1 plus 6x. And that's kind of all you have to do with that. Okay, notice that that is a sideways parabola. All right? So